All right, my friends, we're back on the Perfect Plumbing Plan. We're gonna be jumping into layouts today. I got Ross, the engineer. My name is Matt, I'm a builder, and I got my buddy Eric, who's a master plumber. Let's get going.
Perfect Plumbing Plan, a Build Original series brought to you by SharkBite.
We're back at the vibe board, Ross. You've got a whole bunch of nerdy stuff we're gonna go through today. I can't wait.
Let's nerd out. Okay, so first thing that I always think about is the hot water rectangle. And so what that means is, what is the water compactness of the home? So if you think about it, any house has a layout, and there's going to be a rectangle area that denotes the area that you need to get hot water to, right? So if I look at this typical floor plan layout, I got a garage, bedroom, all of the area that encompasses this red rectangle is the area that I need to get hot water to. So if I take the ratio of hot water area to total conditioned area, that is my hot water rectangle.
Got it. So it's just the spaces to get water. Okay, that makes sense.
So this layout is 1697 square feet total. If I take the area of the red rectangle divided by that, I'm at 67%, right? So that's okay. We can do a lot better than that, all right? So if I go into a really bad example, this is 155%. And people are like, how do I get more than 100%? And look at this. I've got a garage, I've got an outdoor space. I need to get hot water to all four corners of this building.
Wow.
Right? So because I have to get hot water here, and because I have to get hot water here, and because I have to get hot water here, that denotes the red rectangle. If I do the division from this, I get 155%.
Yeah,
Not
that's
great.
a lot.
All right, so we can do much better than that. Here is an awesome house, and this is right from Gary Klein, right? This is one of the best houses that I've ever seen. It's less than 1%. And the red rectangle area would basically be here to here to here. This is it. Because I got my kitchen sink, I got my two bathrooms back to back, right, for hot water here and here with the two showers, and I got my washer dryer right here.
And we're assuming there's probably a basement underneath, so that water heater's, right under here somewhere, and all that water has to do is go up, and it's right there.
It's right there. It's right there.
It's a compactness of plan.
Yep. So this works for condos. This works on the same level because you could actually put the water heater right here, right? You could have the water heater right next to your.
I guess that's right.
Your wash and dryer, right? Or you can have it above or just below.
Sure.
On that note, though, I think it's important to reiterate where we position the water dictates the calculation of the hot water rectangle.
Great
correct?
point. So if this was in the garage, let's say, Eric, to your point, it's not very good anymore.
No,
Or
now
in my
our hot water
case-
rectangle is here, right?
Right.
Or in
Not
the case
good.
of where Ross and I are working and living, we have basements, right? So that water heater can be significantly farther away than, let's say, on a two-story home, the furthest bathroom.
That's right. Yep. So just think about minimizing the distance from the water heater to your fixtures, right?
that's good.
Basically a good way to test it with the hot water rectangle. Now, if I have a two-story home, right? So I have a first story, second story, same thing. I do the hot water rectangle, 325 square feet is my red rectangle. Because it's a very compact layout where the hot water is basically stacked on top of each other, I get a 12% hot water rectangle.
good.
Really good. Really good stuff. Now, Matt, this is your house, right? So we look at the floor plan of your house, right? And the blue area is your hot water rectangle. The red area that's denoted is your conditioned floor space.
Okay.
So I have 1,600 square feet of wet area or hot water rectangle area, and I have 1,700 square feet of conditioned area.
Yep.
And so if I do that plus my second floor, I'm at a hot water rectangle of 59%.
Okay. So,
Right.
okay, but we probably could have done better, frankly.
Yeah, because you got a kitchen sink over here, right? You have your master bathroom over here with the shower there. You have your
Got a laundry facility back here.
That's right. And then second story, if I come up one level, I have this bathroom, I have this bathroom, right? And and I have this shower. So I have to get that encompassing too. So it's 575.
Yeah, and I actually, later, it's not even shown in the plan here, added a washer and dryer set right here, which is just barely in the triangle.
In the triangle, that's right, or in the area. So now, if we go into layout methods, right? So how could we have piped your house, right? So one way is trunk and branch, right? So here's my water heater. Here is my main trunk, and then I have branches that feed off to go to my different fixtures.
Yep.
Right, I can do a zoned trunk and branch. Here's my water heater, and this is one zone maybe going to the first floor, maybe this zone is going to the second floor, right, with the teed system.
Yep.
Same idea, trunk and branch, just two different ways of looking at it. I also have a manifold style or home run style. My water heater, manifold, and then I come off and I run that way to all my fixtures. So this is to a shower, this could be to the master bathroom, right? This could be a kitchen sink, independent runs to every single fixture.
Yep.
And I can also do a single loop for recirculation. Right, so I can have for my water heater, it can go out hot, it can go to every single fixture, and then usually I just add a pump here, and then I complete the loop.
I got a question for you, Eric, before we move on.
Yeah.
Would you say that the majority of the houses in America over the last 50 years have been some version of trunk and branch?
And the majority are going to be the first two up here, the trunk and branch. And when you have trunk and branch systems, you start out with the largest pipe diameter at the water heater, that source, right?
Right here, yep.
The same would be true for cold water, but we're talking about hot.
Yep.
So we have the largest pipe diameters nearest the water heater. They decrease over time. So we have less and less volume, but we also have flow restrictions picking up over time, distances farther away from the heat source. Now we've got longer wait time, more water down the drain before it gets hot.
That's right. Yeah, think about that, like half GPM, lavatory sink running right here. It's got to go through maybe a 1-inch pipe, then a 3/4 inch pipe, then it's got to go out through that 1/2-inch pipe.
Right.
Right?
It's got to take that plug of cold all the way out to the end before it's finally hot.
That's right.
But with the majority being that way, all the plumbers that are out there right now are familiar with it.
That's
Yeah,
right. That's
that's
right.
right.
Very, very common. So if we go to the next one, this is a better kind of layout of understanding, trunk and branch, right? Same idea. Then there's the mini manifold style, right? So it's a variation of trunk and branch because I have these mini manifolds that can hit that bathroom group from one manifold. So it's kind of a hybrid between the central manifold and the trunk and branch, right? Your home run and trunk and branch combo. And then you have your recirc, right? This dashed line represents the recirc getting back to the water heater.
Yep.
Right? Okay, so with your basic DHW piping, right, you got your water heater here, right? You got cold water going in. I'm usually adding fuel or electricity to heat that water, and then my hot water goes out to the fixture or appliance, right? So very, very straightforward, and then goes down the drain. One variation of that is a recirculation system. So now that same hot water goes out, and then it comes back through this kind of like the third leg, we call it, with a recirc pump that goes back to the hot water. So we're priming that loop. So what I can do is reduce the time to tap because now it only has to go from here to the fixture versus all the way from here to the fixture.
Because this loop has been charged with hot water.
That's right.
And these can be this could be running 24/7, like maybe at a hotel.
Yep.
This could be on a timer system. And there's some smart systems that we might talk about even too.
Yeah, so I've been installing these systems for years, and the technology has changed significantly over, let's say, the last 5 to 10 years. This is a Grundfos pump here. It's made out of stainless steel, so it's for domestic hot water, potable. We don't have any worries about what this is going to fit right into our plumbing system, code compliant. What's cool about these systems is they have some really neat technology built into them. It allows us to keep that main line on the trunk and branch hot. And it does that using some built-in sensors, very easy to retrofit into older plumbing systems too. So this product is actually wide varied in its application. We can use on new construction when we plan the plumbing properly, and we can actually use a variation of this to fit into an existing system to provide hot water recirculation in an older home without having to repipe it.
Yeah, the two things I really like about that system is they got to get temperature sensor inside of it, so it knows when it's warm and charged up, so it knows when to shut off, and it can learn your habits. The other thing is that it's an ECM motor. So that thing at max speed consumes 38 watts of electricity.
Pretty small.
And under normal operation, under normal conditions, it's probably gonna be 15 or 20 watts of power. So like a 20-watt light bulb when that thing runs.
It's not gonna contribute significantly to the whole overall energy consumption for this system.
That's pretty incredible.
So then we can go into the different layouts. So if we looked at your house, Matt, and this is the trunk and branch style. So let's say we have the water heater here under the under the stairs. And I'm running my hot water pipe here, and then I have a branch pipe that goes off and feeds your kitchen sink.
So in other words, this would be a 3/4 line probably, or maybe even a 1-inch line.
Yep.
And then we would come on a twig line, a smaller line, to feed this sink area. By the way, I'm slab on grade, so I can't put that water heater in the basement. This is on the first floor. And the other thing I want to mention on this too, Ross, is shout out to our mutual friend Gary Klein. When I originally planned the house, I put the water heater in the garage. And Gary said, well, we could do that, but look how far it is to get to your master bedroom where you've got your shower and your 2 lavs. It's gonna take a while to get hot there. Whereas this guy right here, boom, it's super fast to get it to all of my main fixtures would get used daily.
And closer to your second floor fixtures as well.
That's right.
Right, your second floor fixtures right here. So with the trunk and branch system like this, I've done the math out, and you're gonna have to wait for 57 seconds if this is a 3/4 inch line and then a 1/2 inch branch to your kitchen sink.
To
Almost
get
a minute.
to get hot water at my kitchen sink.
That's right. So if you turn that kitchen sink on, it's gonna be about a minute for hot water to get there.
Well, that's a long time to wait.
I'm not happy about
That's
that.
not very fun.
That's without recirc though.
That's
Right,
without
that's
recirc.
without
Okay.
recirc.
Yep, without
That's
recirc.
right.
Correct. Let's look at the manifold style. So this is like a home run. So let's say I had a water heater here and I had a manifold and I have runouts going everywhere through your house for every single fixture.
So let me draw that just so I make sure I understand. So in other words, from here, I've got a small line, small line, small line. I've got another small line here.
Yep.
I've got another small line to my laundry.
Yep, here and upstairs.
To the upstairs. Okay,
Yep.
so it's just like an electrical system in some respects, right? Where it's got a home run from one location to the direct with minimal fittings, which I really like.
We often even call it a home run system because they're just going from the home base or from the source to the fixture itself.
Yeah, so what we can do is size this pipe to make it be exactly what we want it to be for the fixture group that it serves. But you have individual serviceability of every group, right? So I can shut it off here if I want to service that one bathroom and let the rest of the hot water system run throughout the house.
So if I want to remodel my kid's bath, let's say, I could shut their 2 or 3 fixtures off at the home run system, let the rest of the house run, I'm good to go.
That's right.
Or if I had a leak somewhere, I could turn that one zone off.
Maybe not with your house, but with some houses, this is a great system. There is limitations to it though.
That's right. Yeah. One thing is you cut your hot water time down with this to 29 seconds. So we're from basically a minute to half a minute by doing this, because now we can size a 1/2 inch line going right to your kitchen sink. So you can be more targeted with it. But if you also think about it, I got to run a lot of piping in this house. If I look at the total lengths of pipe, I have the most amount of piping with the manifold home run style. I also don't have any joints. An advantage, I don't have any joints along the way. It's one continuous PEX run there.
Or fewer joints.
Fewer joints.
Maybe not no joints, but fewer joints.
No joints along the way.
Right.
Ideally, it's one continuous line with no interruption in between. Now, of course, that could vary by one line at a time, you know.
Right, but to try to put in a faster recirculation system or something like that here is very complicated to do after the fact.
Yeah, it's hard to do later. And if you were going to do a recirc system at the start, it would require twice as much piping, because if I want to recirc for this kitchen, I'd actually have to run a hot line and then a return line from that kitchen fixture. And the same with every other fixture too, right?
That's right.
It's not efficient. More water volume in the system, more energy to keep it maintained at a hot temperature.
That's right. So we typically only see manifold styles like this or home run styles for very, very compact layouts. So really low hot water rectangles.
So back to your rectangle, like if I have a 1% rectangle, maybe that makes perfect sense.
This is a great solution.
But at my house where I've got a 55 or whatever my
59.
percent it was, maybe it may not be the best choice.
That's right. So really the last option is a recirculation system. So I think of it as more like a single loop that runs around, right? So I can have my water heater here, it goes all the way around, and it basically comes back with the recirc pump back to the water heater. So I'm sort of priming that loop, right? Making that loop warm. And what I did now is I reduced the length of distance from the main to that fixture. So if I reduce the distance there and I get that pipe size right, I can reduce the time to tap, right? Because I reduce how much water I have to use to get that water purged.
And this is what we actually did in my house too, Ross. So this is the winner in my mind. And the thing that I like about this system that could be a pro or could be a con is this is really intended to use a circ pump with.
That's right.
And circ pumps are not free, right? They do cost some money, but what it gives me is very quick time to tap.
That's right.
I waste very little hot water at my house.
So the math on this layout is 10 seconds to your kitchen sink for
That's
water.
pretty amazing.
So from 60 seconds to 30 seconds to 10 seconds.
And we're gonna head there for the next episode, but the other thing I think is really awesome is by putting that water heater in this spot, I know we talked about this already, my piped feet to these locations is so quick, it doesn't have to be on my circ line. You can actually see those leaving from my water heater closet, which is off my stairwell. It's crazy, and we'll actually go time it later.
That's right.
I want to point out one thing though. So this is addressing new construction really, right?
Right.
It's harder with retrofit applications. If we can plan ahead of time the piping system, which is what we've been talking about this whole time.
That's right. It's a planning episode.
Yeah, and so we can then run that what we call a dedicated return line.
This right here, this coming back. Yep.
That last bit of piping from the farthest fixture back to the heat source, the water heater. That is critical in this application. We can do hot water recirc in a retrofit as well without a dedicated return. So anybody watching this that isn't building a new home, we can do this. We'll talk about that a little bit later in another episode.
That's right.
Yeah. I like it.
Yeah, and the other thing too is that second bathroom group that's off on the second floor, if I can reduce that distance, it's the same thing, right? I've reduced it to maybe 6 feet or 8 feet from that loop. Again, time to tap everywhere has been enhanced with the Recirc pump.
Ross, this may be a discussion for later, but the other thing I liked about this was this allowed me to use a 3/4 inch main Recirc loop line in 1/2 inch drops. Because one thing that we haven't quite talked about yet, and we're going to get to it in a minute, is you may or may not be able to use smaller than a 1/2 inch pipe to feed your house, and we'll talk about that in a minute. But in this case, it made everything really straightforward to plumb with a 3/4 and 1/2 inch.
That's right, 3/4 main and 1/2 inch runouts.
I used PEX A on my house and really was cautious about reducing the number of fittings. I was really trying to use the least amount of fittings as possible.
So the other thing that's really, really important is thinking about the hot water use in terms of the draws, right? So when you think about it, the water has to be delivered, right? So this is getting it delivered, and then it actually gets used, and then the pipe then cools off, right? So if I have really sporadic usage, meaning I use the hot water and then I don't use hot water, right? I'm losing that heat and losing that energy. So this is the part that's most useful to me, right? That's the part that matters the most. Okay, so one thing to be aware of that is how fast do the pipes cool down.
Okay.
And I think one of the things that's really, really eye-opening, at least that was for me, is that when you compare PEX to copper, PEX actually retains its heat better than copper.
Oh, that's shocking.
And for two main reasons. One, copper pipe that's bare is going to radiate heat really, really well. That's why we use it in hydronic heating systems. It emits heat. It does a really good job of radiating. The other thing is that the plastic PEX has a little bit better of insulation natively because the PEX is plastic versus the copper, which is metallic, and so it has a little bit more insulation built in. And so if I look at it, if I look at 3/4 PEX and I look at 3/4 PEX insulated compared to 3/4 copper bare, right? So let's just look at bare copper to bare PEX. This is how much heat do I lose over time, right? So if I look at 3/4 PEX, I'm gonna lose heat like that, right? It's gonna be down probably about 7 to 8 seconds. If I have bare copper, I'm gonna lose heat, minutes, thank you. And it's gonna be about 12 minutes for it to lose heat.
Yeah.
Right? And then the same thing, if I insulate it, if I take 3/4 PEX and now I insulate it, it's gonna be out to 25, 30 minutes. So now if I have those sporadic usage, I might be able to retain that heat over 30 minutes to get ready for the next shower.
That's pretty amazing. Eric, give us some advice on pipe insulation. My guess is you've wrapped a lot of pipes in the day.
Yeah, well, first of all, a couple things. I think there's a slight misunderstanding, or could be, with what you said a minute ago about PEX holding the heat, retaining the heat a little bit better. I think people understand that, but it's not as if PEX doesn't need to be insulated.
Right.
Right.
Very
Okay.
key.
So we do need to insulate the PEX. Now the performance numbers you can't argue with, right? We see it on the graphs, pretty easy to understand. The materials though, we use a lot of vapor closed materials. So like this is put out by a company called Armaflex. That's a brand, but it's like a rubberized.
It's a closed cell foam,
elastomeric foam.
Yep.
And so what this will do is it fits tightly, so it's size per pipe size.
Yep.
Also, we want to match the wall thickness to the size of the pipe. So that's actually a code stipulation. I have to plumb under what's called the Uniform Plumbing Code, the UPC. My code says that the insulation wall thickness has to match the diameter of the pipe.
Okay.
Up to 2 inch, then it gets to be a little bit different. But we're dealing with residential size piping, so 3/4 inch pipe, 3/4 inch wall thickness on our insulation.
That's right.
This is flexible, easy. It's self-sealing because we've got like a adhesive pull strip on there.
That's right.
And you can actually, which is very interesting, maybe not a lot of people know this, you can buy pre-insulated PEX piping in coils. Very useful because it's now skips an entire step. Maybe it takes a slightly longer to install it physically, but you skip that entire step.
pretty nice.
Yeah, and you don't have the seam, right? The seam goes away.
So it is a solid piece of insulation with no seam in it.
By the way, I've heard people say, and I think this is a Gary Klein, say don't put the seam up because over time if something happens, it could fall off the pipe. Whereas if you oriented that seam down, it's not going to fall off. That's, as my kids would say, that's DTM.
There's actually a lot of, I don't know what that stands for.
Doing too much.
Okay, doing too much. Okay, so
Educated you. Old dad's there.
A couple things to note, though.
DTM.
There's different types of insulation, right? They're not all equal.
Correct.
And we talked about the sizing of it. What's really important, though, is that we don't leave any bare spots in the piping. All of this needs to be sealed up. Anytime we allow like a gap in the insulation, maybe have fittings if they're not cut tight and fit together nicely, you're allowing that pipe to be exposed, which is going to decrease the effectiveness of the insulation.
Yeah, that's right.
And one other thing I'll add about this is that if you have the distribution piping in a joist bay, right? You have a cold water line, a hot water line, maybe a recirc line. It's always best if you can put the cold water line in the next bay over.
Yeah.
And the reason for that is that the hot water line and recirc becomes basically like a heating loop. It's going to heat up that joist bay. So if you can move the cold water to one side over, it's going to prevent heat loss and heat gain of this pipe.
And I would tell you, insulate both your hot and your cold, frankly.
Absolutely.
I think it makes a really big difference, both in a really cold climate where your inlet temperature in Minnesota might be, 40 some degrees. And in Austin, where I am, it's 60 degrees. So I think insulating your hot and your cold is the way to go. The last thing I want to mention is you get what you pay for when it comes to pipe insulation. Don't use the thin wall cheap stuff. Get the good stuff. Look for an R3 or 4 value. This is worth paying for.
Yeah.
That's right.
It pays for itself over time. For sure.
So if we're looking at the UPC, right, the code in your area and a lot of areas around the country, they do have minimum pipe sizes, right? So we want to stress getting the pipe smaller, but we really want the code to really catch up, because if you look at the UPC, the smallest pipe you can use is 1/2 inch.
Yeah.
1/2 inch is the smallest they'll allow in the UPC. And if you go to the IPC, the International Plumbing Code, you can see here, it's 1/2 inch. They do allow you 3/8
In a drinking fountain
drinking
situation.
fountains. Yep.
That's interesting.
And then you also get it you get the 3/8 down here for laboratories.
Oh, yeah, interesting. So you could plumb your sinks in 3/8, but as we've been talking about here, you might have showers that really could easily be fed with 3/8, no problem.
Exactly right.
Right?
Or a lot of
Exactly
the
right.
other sinks that are on that chart. Now, some of this is commercial, of course, but our piping sizes are stemming from the 1920s or 40s, somewhere around there.
Yeah.
Where
Yeah,
we had
a long time ago.
basically one type of piping, which was iron pipe, cut and thread,
Yep.
like galvanized. We didn't have fixtures that were using very small amounts of water.
That's right. That's right. Yeah. So the plumbing code, I think, across the country could be updated for some of the lower flow fixtures that we're really seeing, and hopefully we can get 3/8 used for more fixtures, around the home.
And I would tell you, if you're a builder watching this, there's companies like Ross's company that will design and engineer this for you, that you can then take an engineered plan to your city jurisdiction and say, hey, I've engineered my plan. My engineer says I can use these pipes here.
Yep.
They may not meet the UPC's designation, but my engineer says they work with my PSI, with my fixtures. He actually knows the flow of the fixture, all these things. And I would also tell you, make sure you talk to your inspecting department first before you hire an engineer to make sure that they will accept that.
That plan. Yep.
But if you're watching this and you have anything to do with plumbing codes, think about making an update on this in the future.
That's right. That's all we got on this. Let's break it down at the desk.
All right.
I wish there was a training facility we could actually test this stuff out.
If only.
I've got something for you guys.
All right.
All righty.
All right, so RWC's training facility is really cool because we get to see behind the wall. We've been talking about the distribution piping and the different styles. You saw it on the blueprints. I think this gives us an opportunity to see just what we're talking about when we talk about the different styles of distribution. I'm gonna walk you through really what's here. We're gonna talk about distribution and getting the piping system closer to the fixtures, the heat source closer to the fixtures, okay? Now, of course, this isn't making any assumption that houses are gonna be designed this way with everything so close, but we can look at how the piping is routed to see how it affects, that distance affects performance. Got an electric water heater on display here. It's actually, all of this is working. Got a meter, so it gives you the full context of what you're gonna see in a normal installation. Piping mains, this is the trunk and branch style, right? We've got 3/4 inch mains feeding and coming off of the heater, going up into this truss space above us. Now consider like a two-level house or a 2-story, and you're gonna have these open web trusses or joists, and you're gonna get your distribution up into there so you can get it further out to the bathroom groups, the kitchen, stuff like that. These 3/4 inch mains are gonna have a couple takeoffs and make use of this flexible piping really nicely, but getting the idea of getting the pipe closer to the fixtures to reduce that hot water triangle is what's on display here. I like that we've got multi-port manifolds or T's, we've got regular T's, the trunk and branch style on display very easily to show you how flexible and versatile PEX piping is. Also, they got a really
done a nice job just showing the different kinds of terminations and support systems. But let's pay attention to pipe size, right? We talked about downsizing or right sizing that pipe. If we have the proper pressure and the proper flow rates, we can actually go down in size, because what we've been sizing piping on from the very beginning, from our establishments of our code books, is 1940s or so technology. Back then we didn't have faucets, so we're only using a half gallon per minute. We didn't have showering systems that also were using mega amounts of water, right? Everything has changed a lot, including the materials. How we've been putting it in, though, hasn't changed that much at all, right? Even with the technology changes, our first approach is just that idea that we've got to get large piping, get smaller as it goes along, and then we distribute it and make that final terminations at the fixtures. We want to try to get the piping smaller by moving that piping closer, the heat sources. On display, we're doing that with their product here. I think they've done a great job at that. It's really cool to see it without the sheetrock on, right? So this is what I see when I'm putting the piping in, gets covered up. I don't really love that. It's not my favorite thing as a plumber. But ultimately, the functionality is what makes sense here. Even if we worked outside of the constraints of our code, we could make the case where all of this piping that we see in the walls could actually be smaller, believe it or not. So we've got 1/2 inch drops, we've even got some 3/4 inch, and then teeing off to serve multiple fixtures at once. If we were using more updated code methods on sizing this pipe, we could easily see this pipe go down to possibly 3/8 or even 1/4 inch to lessen that volume to deliver that water faster. Pretty cool display. I love seeing this kind of stuff because, of course, I'm the one installing this. I fix it. I know what it looks like behind the wall, but I like sharing that with you guys. I want to thank RWC for having us out here too. This is a fantastic facility.
Ross, let's break it down. I think the biggest thing that Eric said at the very beginning of the series was, boy, it really frustrates his customers when they have to wait for hot water.
That's right.
Now that you've broken down the 3 systems, we've talked about Recircs a little bit. If you're building a brand new house, what's the quickest time to hot?
Typically, I would say for a normal house in America, I would go with the highest time to tap. It's going to be a Recirc system. It's going to be the best way, especially for a hot water rectangle that's pretty large.
Yep.
Right?
Yep.
Most architects that are planning and building these houses and designing these houses don't have hot water in terms of, you know, an optimal plumbing layout in their minds. It's just not.
Yeah.
The master bathroom is on one side, the kitchen sink is completely on the other side of the house, and when you put those fixtures so far apart, the recirculation system really becomes the way to solve that.
Yeah, that's right. We are going to talk a little bit later in this series about hot water heaters specifically, and we're going to show you some options. But I think it's really good advice, especially for architects and designers watching.
Yeah.
This hot water rectangle that you talked to us about, let's think about that ahead of time and design the house with those systems in place. Because honestly, you may not need a recirc pump if you really design with that really small band of hot water rectangle like what we saw.
We see so many houses that when they're designed properly, we can get away with a mini manifold, a home run system, mini ports, and we don't have any recirc system, and you deliver hot water with less than 10 seconds.
That's
So
amazing.
it can be designed right without a recirc system, but it does take that proper planning up front to get it right.
Yeah. Eric, I wanted to ask you about leak risk. When you think about trunk and branch versus manifold versus the circ system that we've kind of landed on as what I plumbed my house with, talk to me about leak risk within those systems.
All right, with branch and main systems, we're using a main line. We're teeing off with the fixture branches or the twigs, like you guys like to say. I love it.
Fixture branches,
I love it. We're our branch line to our fixture, right? Off the main. There's, for instance, with one single tee, we've got 3 connections. That doesn't matter if we're using a push fit system, a PEX system, copper, any type of tee. It's a minimum 3 connections. As we go along, there's multiple fittings throughout the system.
Yeah.
The fittings also provide or impose a pressure loss on the system. We talk about that a lot. So the further we go away from the water heater and the more pipe and fittings we impose on it, increase pressure loss. That's not ideal, but leak control itself, if we can start to eliminate some fittings, we can see less leak pass, less risk. So how do we eliminate fittings? One way, which you proved pretty easily to see, was the home run system.
Yeah.
If we run a 1/2 inch line from a manifold at our water heater to the fixture, no matter how far away, but we don't put any fittings in there, now we have a lot less leak paths because we eliminate some fittings along the way. And also we increase flow rates. That's pretty nice. Hard to recirc on that. But then there's some other different types of systems too, to where you can kind of start hybridizing the system. So trunk and branch is really good because we can do recirc with it pretty easily. And we can also use things like multi-port tees, some specialized PEX fittings that have been out on the market for quite a while that'll eliminate some connection points too. So this is basically, it's 4 connections instead of 6. It's 2 fittings in 1, right? Kind of nice.
Pretty nice.
This actually has more. It's 5 connections instead of, how many is that? That's 4 times 3 is 12 taking place there, right? So we eliminate leak paths by eliminating more connections to the fitting.
I've heard you say this too. If this was at the end of your trunk and branch system, you might have a lav getting hot water, a second lav, and a shower. But then you've got this extra port that could be used for a recirc line to the end of a trunk and branch system.
It's a beautiful way to use fittings like these. We call these multi-port tees, and they're available from a lot of different manufacturers. These are SharkBite brand, PEX A, and I like them because it allows me to get my main closer to where the fixture branch takes off. So if I can get my main closer to your upstairs bathroom, right underneath it, and then only have, let's say, 5-6 feet to that fixture, because of a fitting like this, I have less fittings. I can provide recirc on that trunk and branch system, and I have less leak paths. It's pretty nice. Again, they've been around for a while. They're not entirely new. I just don't think a lot of people know about them, and it makes the installation overall more efficient and take less man hours.
Guys, we've got more to go, but one thing I want to encourage you for our watchers out there, whether you're a builder or a homeowner watching, if you've got a project coming up, talk to your plumber about this. Maybe watch this together. Maybe send them this video series and talk about this, because what we're talking about here is really changing the mindset of the industry. We said this at the beginning. We've been kind of plumbing our houses pretty much the same way the last 40, 50 years. But if we can think about how we do it, we're still using great products like we've been, but do it in a more thoughtful way ahead of time. Maybe sometime using an engineer to do it. Maybe just getting together with your team and thinking about it ahead of time, before the plumbers show up or before the install team from the plumbing company shows up. Really getting these things right means that we can reduce that #1 callback that Eric said at the very beginning of the show. Next episode, we're gonna actually go out to my house and we're gonna do some testing and see how it worked. We're gonna show you what we did right, and I might have made a mistake or two as well that I think we can correct. Guys, we got more to go here on the Perfect Plumbing Plan, but with that being said, we'll see you next time on The Build Show.
Perfect Plumbing Plan, a Build original series brought to you by SharkBite.